In the whiteboard lecture, we have discussed about parameter passings. So let us have a demonstration for those parameter passing. See, this is the example program which I have used in the demonstration for functions. And this function is for adding two numbers. Which parameter passing method this is using? See, the arguments are int a and int b. These are normal data variables. So this is call by value mechanism. The parameter passing is call by value. So what happens here is the value of num1 and the value of num2 will be copied in a and b respectively. So values are passed here. In this type of parameter passing, if any changes are done to this formal parameters, that will not change actual parameters. I will explain you what does it mean. So for explanation, I will do comment on this. Okay, return, I don't have C, so I will just return 0. Leave it. Now, here I will show you. I will make changes in this parameter A. So value of num1 is copied in A, but inside this function I am changing A. Will it change num1 also? No. In call by value, this actual parameter will not change. A will change. This A will change. If I print this A here, then you can see that the value 11 will be printed, because from here I am passing 10, that is num1. It goes into A here and A++, then A is printed, 11 will be printed. But here I will comment this, and before this I will print num1. Just check. This num1 will still remain 10. This proves that when the value of A, that is formal parameter, is modified, it is not reflected in actual parameters. Let us run and check. Oh, there is no space, so I should add a space here. So I will give endl before printing num1. Yes, see, this is the value of A and this is the value of num1. Num1 is still 10 only, right? Value of A has changed but not num1. That is the meaning. If the formal parameters are changed, then actual parameters will not be changed. This is in call by value. Then the question is, when to use call by value? Call by value is used when you want a function to process something and return the result. It should take the values and return the result. That's it. So this is a suitable function, adding two numbers, or finding maximum of numbers, or finding greatest of n numbers, or maximum of n numbers, or checking a number is a palindrome or not. So these type of functions which will take some parameter and return the result. When it is not modifying actual parameters, it should return a result. If a function is modifying the actual parameters, then it may or may not send some result. It may not be mandatory for it to send the result. So it depends on the situation. So question arises, in what situations we should use call by value. So call by value should be used when a function has to just process, that is do computation, get some results and return those results. So then we should use call by value. So this is a suitable function. Alright, so I have explained about call by value and when to use it. Now let us look at an example of call by address. Call by address. So I have to change the code. I will write down the swap function, then I will explain you. Here I have an example of swap function that is using call by address. So first of all, I'll explain you the syntax and then when to use call by address. See, the syntax is call by address, the parameters should be of type pointers. They take pointers. And when you call a function, we pass the address of actual parameters. The address of actual parameters are passed and that are taken in formal parameters, and the formal parameters are pointers. So these pointers will be indirectly accessing these values itself, so number 1 and number 2, that is num1 and num2. So if you see this is the logic of swap, right? Logic of swap. And these are pointers, so I have to use dereferencing operator, that is star x and star y, for accessing the value. So star x means it will access num1 and star y means it will access num2, this value itself. Now after calling swap function, if I print the value of num1 and num2, they will modify because this function has modified these actual parameters. Num1 is 10, it will become 15, and num2 is 15, it will become 10. So if you see the values here, here you will get 15 and here you will get 10. So in call by address, the addresses of actual parameters are passed. They are taken in pointers, and the pointers can indirectly access actual parameters using their addresses. Alright, now I will execute it, then I will explain you. See, first number 15, second number 10. So this is 15 and this is 10. Their values have changed, right? It has swapped the value, interchanged the value. So this is called by address. Now when to use, in what situations we should use. See, this swap function is modifying actual parameters, so it is not returning anything. We don't have to return anything. Whatever the results of this function, they are directly reflected inside actual parameters, so it doesn't have to return anything. In some situation it may return something. So when you want a function to directly work upon the actual parameters, then go for call by address. Then one more situation. Here you can see that swap function is modifying two variables, num1 and num2, but a function can return only one value. We want two results from swap function, so better use call by address. Now third point, if you have some variable and you want the same variable to be modified, then send it as address. Send it by address, call by address, right? So here we are having just integer type variable. Suppose you have an structure type variable or an object in C++, then it's better to send it by address, call by address. All right, next parameter is call by reference. So this is supported in C++, and first of all we will see the syntax, then we will see when to use them. So the syntax is, here in formal parameters you have to write ampersand instead of asterisk, so they become references. And references you don't have to write star for accessing the data, right? Then remove this ampersand from here. This is the change in the syntax. Already I have shown you on whiteboard. So the syntax is simple, but the mechanism and the working and the performance is same as call by address. But one more thing I have to say, in C++, the concept of references, it is a nickname of a variable. So it should directly represent num1. It is not a pointer, it will not hold an address. X means num1. So this is possible with the help of inline function. So C++ supports inline function. So this swap function may become inline function. Not it will compulsorily, it will not become inline function. This may become inline function. It all depends on the compiler, right? It all depends on the compiler. On the whiteboard I have said that this may become a inline function, but it's not mandatory always. It depends how a compiler implements references. Conceptually, references are nicknames, they are not pointers, right? But compiler may implement them as pointer. How a compiler implements, we can't say. But there are two possibilities, that a compiler can convert the swap function as an inline function and copy the entire code here, or it can make these as pointers also. So the syntax is simple, but the working is same as pointer. That is the benefit a programmer is getting. That's all about parameter passing. Now few more things. Like if I have two variables and one I made it as call by reference and the other one is not call by reference, then will the compiler make it as an inline function, swap function? No, it's not possible for a compiler to do. Only one parameter is call by reference, so for the other one is not a call by reference, so definitely it will not make it as inline function. But again, it all depends on the compiler, how it's going to generate the machine code, right? We can't say that unless and until you get the output of a compiler and see it. So from the observation, you can say the results given by compiler. But conceptually here, one is called by reference, other one is not called by reference. So definitely it is not going to be an inline function. If I have one is called by address, yes, it is possible. You can have one as call by value, call by reference, and one by call by address. You can have different type of arguments. All right. So this function is using call by reference also, call by address also. All right. So we cannot use single name for parameter passing. For each parameter, we give the type of mechanism used. X is passed by reference, Y is passed by address, right? We don't use the parameter passing mechanism name with a function name. We give it to the parameter. All right. So this is mixture of mechanism, parameter passing mechanism. All right. So that's it. So this all about parameter passing, and I suggest you try to check all these by yourself once and learn how they are working so that it is easy during the course.